Hello friends. Firefighting system in a building consists of three parts. 1. Storage tanks. 2. Pumps. And 3. Network of pipes. Let us understand water tanks first. Water tanks are located either underground, at ground level, or on top of the building, or combination of elevated and ground level. It is essential to ensure that the store of water always remains full. In buildings, these tanks are separated from the tanks used to supply water to occupants, which are usually called domestic water tanks. Water must flow from the municipal supply first to the fire tanks and then to the domestic water tanks. Now the question is, how much water should be there in tanks? As per building codes, the buildings are divided in three parts depending on its use. That is, light hazard, medium hazard, and high hazard. Light hazard buildings such as schools, residential buildings, and offices. Medium hazard buildings such as factories and warehouses. And high hazard buildings such as foam factories, aircraft hangars, paint factories, firework factories, etc., which store or use flammable materials. The quantity of water to be stored is usually given in hours of pumping capacity. Suppose pumping capacity is 1 hour, then the tanks are made large enough to supply the fire with water for a period of 1 hour when the fire pumps are switched on. For example, building codes may require light hazard systems to have 1 hour capacity and high hazard system for 3 to 4 hours capacity. Now let us understand fire pumps. Fire pumps are usually located in a pump room, which is located very close to the fire tanks. Like all important systems, there must be backup pumps in case the main pump fails. Generally, 4 types of pumps are used in high-rise buildings for firefighting purpose. Number 1. Jockey pump, which is electric driven and fully automatic. Number 2. Main pump, which is electric driven. It starts automatically but needs to switch off manually. Number 3. Backup pump, which is diesel driven. It starts automatically but needs to switch off manually. And number 4. Sprinkler pump, which is electric driven. Each of these pumps is capable of pumping the required amount of water individually. They are identical in capacity except jockey pump. Jockey pump is a small pump which continuously switches on to maintain the correct pressure in a distribution system, which is normally 7 kg per centimeter square or 100 psi. Jockey pumps should be sized for 3% of the flow of the main fire pump and to provide 10 psi more pressure than the main fire pump. If there is a small leakage somewhere in the system, the jockey pump will switch on to compensate for it. The pumps are controlled by pressure sensors. When a firefighter opens a hydrant or when a sprinkler comes on, water gushes out of the system and the pressure drops. The pressure sensors will detect this drop and switch the main fire pumps on. During fire, due to any reason, if electricity fails, then these electric driven pumps will not work. Hence, diesel driven pump is required as a backup pump. All pumps except jockey pump, once they are started, the only way to switch off a fire pump is for a firefighter to do this manually in pump room. This is an international code of practice that is designed to avoid the pumps switching off due to any malfunction in the control system. The capacity of pump is decided by considering a number of factors such as the area covered by hydrants or standpipes and sprinklers, and the type and layout of the building. Now let us understand network of pipes. The distribution system consists of steel or galvanized steel pipes that are painted red. When running underground, they are wrapped with a special coating that prevents corrosion and protects the pipe. These are basically 2 types of distribution systems: automatic wet system and automatic dry system. Automatic wet systems are the network of pipes filled with water connected to the pumps and storage tanks, as described so far. Number 2. Automatic dry systems. Automatic dry systems are the network of pipes filled with pressurized air instead of water. When a firefighter opens a hydrant, the pressurized air will first rush out and then the water comes out. This is done wherever there is a risk of fire pipes freezing if filled with water, which would make them useless in a fire. In high-rise buildings, it is mandatory that each staircase have a wet riser, a vertical firefighting pipe with a hydrant at every floor. It is important that the distribution system be designed with a ring main, a primary loop that is connected to the pumps, so that there are two routes for water to flow in case one side gets blocked. In more complex and dangerous installations, high and medium velocity water spray systems are used, and for hazardous chemicals, foam systems are used. The foam acts like an insulating blanket over the top of burning liquid, cutting off its oxygen. Special areas such as server rooms, where the contents of which would be damaged by water, use gas separation systems. In this system, an inert gas is pumped into the room to cut off the oxygen supply of the fire. So friends, see you in the next video. Thanks for watching.